Swayam Prabha. Digital India. Educated India.
Hello, Namaste, welcome back to the course on Geographic Information System. In my previous class, we had started looking at what do you mean by an overlay, what do you mean by overlay on a point on a polygon basis or overlay on vector asset. Now, as in such, we will continue with the same mode. We will again go forward and understand with certain examples. In the last class, I had given you only a theoretical overview of how this overlay analysis and how do you use it in your analysis or a buffering analysis, how do you do it. But now let us see in as a practical part of it how different things are applied at different contexts. Okay, this specific class is an extension class of the previous session, whatever I have spoke in the previous session, and this is exactly the thing that theoretically that I had given. I would put it in more in a practical purpose. So, okay, so I would speak today on point in polygon analysis. I spoke about how vector on vector data is possible. I spoke about polygon and points. I spoke about polygon overlay, point in polygon overlay, and also I spoke about how you can utilize it for various analysis. So, I would take it forward. I would look at the same aspects as I spoke in the previous class. Then operations on overlapping entities. How do you do an operation on overlapping entities? Then the vector overlay is the same, I would not stress much. Then the distance relationship I have already spoken in the previous class, I would not pick up much here, but that is one of those things that you have to see when you are looking at how the distance is measured and how it is actually changing. Then we look at the buffering part of it, what are the different buffers, how buffering is an issue, how the buffering can be utilized for various analysis, then the connectivity. Now, when we are looking at point in polygon analysis, for example, there is one problem here. So, if you have this is a polygon, this is a circular polygon, so you have 2 points that are here, but there is only one point that is actually crossing the polygon, which means to say that this point will be highlighted in as a simple case of point in polygon analysis, which means it is either indicating a specific property of that particular polygon, okay, or it may be a qualitative or it may be a quantitative issue. But when you are looking at any complex issues, you may see that there may be a lot of crossings of a particular polygon. If you look at here, these are 2 points, and if you take a point B, there is 2 crossing, and where if you take a point A, it has 3 crossings. If it is done, if you are trying to understand a cross sectional analysis in this particular study. So, that is what is a point, that is how a point in polygon analysis is done. For example, if I draw a line like this and try to see that particular point, how it is analyzed over a particular region. Okay. So, if there are more crossings of a particular polygon by a point, then it becomes a complex problem. When it is only one or maybe even 2, becomes a more simpler problem, which is much easier to solve in any of the polynomial equations. Okay. And the third one is the problematic issue, where there is a point on the boundary, or some point is outside the boundary and some point is inside the boundary. So, the such issues are more of complex. So, you have to either understand what percentage of that polygon is actually indicative of this particular point. So, to find that your polygon, you have to understand the features of your polygon, the shape of your polygon, and then try to weigh in what is the characteristics of that polygon. So, these are certain issues that you may face when you are looking at the overlay analysis. And when we look at the entire overlay, for example, if you have number, let us say, as I previously said, why I have shown you this specific image is that to tell you that whatever there may be a number of layers that you have. Let us say someone is working on urban floods. So, they have developed the drainage network, the urban area map from maybe 2 decades map or a 3 decades map, they have digitized, they have done the classifications, etc., whatever it may be. Then they have the ward boundaries of each of the maps, then they develop an natural drainage system, they develop the slope, the hillshade. So, all of these quantities they have developed. Now, that person has to look at what are the different quantities which are actually causing the urban floods. So, now you overlay one on another. For if you have all those different layers, so we overlay one on another using certain quantitative ratios. For example, if I say that I will weigh each of these layers at a particular weight. So, you will adopt maybe any fuzzy analysis, which is advanced spatial analysis, or it may be your AHP. You try to say that this is the weightage of this particular layer, or this is the importance of this particular layer in this particular analysis. So, with that you will also find out where actually the drainage network is blocked and where the flooding is happened. So, if you can understand that the flooding is happening because of the blockage of drainage network, then it is highly sensitive area. So, that is how you can come up with a flood vulnerability map, which is actually addressing the urban floods in that particular region. So, that is one example that I have just mentioned. So, you can have any number of layers, any number of quantities, but these layers have to be utilized in analysis. For example, if you are using an economic layer, okay, in your urban floods, so that gives you a different angle of analysis of this particular analysis in urban floods, but it may be useful for certain section of people who are actually looking at your model. It may not be useful for many sections of people who are looking at your model. So, the amount of data that is necessary, the same data you will use it for different kinds of analysis. That is why overlay analysis is extremely useful in GIS. Okay. So, just to give you another example, this is one of the examples from one of the research papers. So, when you look at it, I have ward level boundaries of a particular place. Okay. Then I have another vector layer which is actually giving me the vulnerability region, okay, of anything. Now, this is just an example. Okay. Now, I overlay one on the other. So, once I overlay one on the other, I know which area is actually vulnerable. Based on this, the output will be the vulnerability map of both the layers which are overlaid on each other. Okay. So, that is exactly the example of the application of why you do an overlay analysis. So, if you have a physical layer, okay, let us say you have 3, 4, 5 physical maps of all these layers, you take a printout, use it, but you will not be able to understand which region overlaps on each other and what is the quantification of each of this layer. That can be done using GIS. That is why GIS is a powerful tool. Then you have vector overlays. So, when I say vector on vector overlays, it may be both point in polygon and line in polygon. Okay. I have discussed already the point in polygon. This example gives you exactly details of planning of how you can look at a planning map. Now, there is a meteorological station point map in these 3 regions. Now, I want to know what is the rainfall in that particular region and what is its corresponding class in that particular region. Now, these are the 3 meteorological stations. So, I have values, attribute data that is attached to it has the amount of rainfall in that particular region. Now, I have a map which is actually a forest map versus a non-forest map. Okay. Now, I overlay one on the other. So, let us based on these overlay, I find out in that map what is a particular land use and what is other attribute information such as its rainfall, etc. Okay. So, now I will be able to find out whether on a broader level, it is not exactly on those details, but it is on a broader level you will say whether forest has certain influences on rainfall or rainfall pattern. The second example here is line on polygon overlay. So, for example, here you have a line map, okay, this is a road line. This, let us say that there is a road that has to be built, a newer road connecting two places. Now you have to produce an environmental impact assessment report. So what the best thing is do is get an forest, non-forest or vegetation map of India from various sources. It may be from Bhuvan, it may be from MOF website or any of those sources. Then you have a road map. Okay. So now once you have a road map which is a line, okay, then you have a forest, non-forest area which may be probably most of it is a polygons. Now I overlay one another. Okay. So now I know where actually it is crisscrossing each other. Though a new ID is allocated, it tells me this particular line where it is crisscrossing is forest or non-forest. Okay. So which means to say that I can do an analysis on understanding how it is actually environmentally impacting a particular region when such development projects happen. That is why you can use overlay tool in much bigger context. Okay. So there, for example, another example is you have a resort that is coming up in that region or it is proposed. So use simple tool is use a Boolean operation, Boolean union operations. Okay. When I say union, it is OR. So once you do a Boolean operation, you can find out where that particular project is proposed. Once you understand where the project is proposed, you can take a decision. Anyone who is considering a policy decision or who is a policy maker can easily say that, see, this particular region cannot be allotted for the resort because it is in the forested region and the forested region cannot be converted as a commercial activity. Okay. Where, or for example, if let us say I have a forest map, I have a resort map. Okay. So if I want to know that how much percentage of forest falls into this resort area, as simple as this, use a NOT operation of Boolean. So what I am trying to imply is that any operator can be easily applied in any kind of analysis in GIS. Only thing is that it has to be logical. Okay. So in the third map, if you see, there is again a forest and non-forest. Now I am doing an intersection, which means AND operator. So it is intersecting both of this map. When I intersect, it means to say it gives me the exact area where the forest is there. Okay. I have just a forest map, I do not have a non-forest map. Now once I intersect, non-forest area is completely removed and I get only the forested. Now again, a decision maker can easily consider a decision of whether that land has to be allotted there or not, as simple as that. So this is where overlay plays a very important role in giving us important decisions on how that particular operations can be used or utilized for providing directive informations. Okay. So there is the next thing called as distance relationship. Yesterday I have spoke about the distance relationship, but when you are looking at distance relationship, you have operations that depend on simple distances between A to B. Let us say tomorrow you decide, for example, you will develop a map of your institute. Once you develop a map of your institute, you should make it more dynamic. So what you will try to do is that if anyone who is entering the institute, you will have to tell them what is the distance from a point A to point B and how to reach them. Okay. So how do you do this? Basically you will have to look at the shortest distance route, the different routes that are there in that particular institute, and this are then used by nodes to calculate the distances. Okay. The best way to do this is use an by using a buffer, help of a buffer. Okay. So how do you do this? Basically, first I will draw a zone around the initial entity where the boundaries of the zone are all distance d from the coordinates of the original entity. Okay. Now buffer, both buffer that is outside and the buffer that is inside. So when I say buffer that is outside, that just outside the entity that you are representing, and buffer inside is the inner entity of that. If you take a 5 kilometer buffer, 2.5 is an outer entity and 2.5 is the inner entity. So that you will look at. Then you will look at the circular, the rectangular with the rounded ends or irregular lines or a polygon. What kind of polygon can connect these? Once you have understood, once those polygons have been drawn or lines have been drawn, then buffer to the newer polygon using a temporary aid can be done using a spatial query. So, which means to say that once you start locating that particular region to reach that particular point, then you will say that this particular by any query, how do I connect these two polygons or these two lines or these two points. So, once you have connected those 2 points, then your route is actually established. That is how you do it. Okay. So, now for example, this is exactly what I was speaking. So, you have this, you have to reach this point from this point. Okay. So, this is the distance that you have to calculate. Now, you draw a buffer. Okay. Now, this part is a outer buffer and this part is the inner buffer for this region. Let us say from the point, if this is the entity, this is outer buffer and this part is the inner buffer. Now, with this outer buffer and the inner buffer, what you try to do is that you will find out how the lines connect each of these points across those lines. Okay, if there is already a set of road. Okay. Now, you will draw several buffers in this region. Okay. Based on this particular point, you will then try to trace this particular line. So, this line is actually connecting these 2 points. So, once you have found out that it is connecting those 2 points, then you calculate what is the shortest distance and other buffer regions which is the shortest distance. Once that is calculated, that is how Google gives you the shortest distance, and maybe you have 2 or 3 more distances that is actually put out there. So, it says that this is with tolls, without tolls, you have this distance. So, those are based on the database information that you have when you are actually traveling. Google would have collected all the database information either through surveys or either through its manual inputs that it may have it in its database. Okay. So, this is one example of buffering. So, when you are looking at a buffering, you can do a line buffering, a point buffering, or it can be a polygon buffering. Okay. So, when you are looking at a line buffering, so you are actually looking at what is across the line. So, effect is across the line. Then if you are looking at a point buffering, what is the effect around the point, and when you are looking at a area, you are actually looking at every point on the area, what is the effect on every point on the area from the buffered region or the buffered source. That is exactly why you need a buffer point, line and a feature or an area in order to look at its analysis. So, very good example is that, for example, I have, let us say I have planned a new metro line that is coming up. So, now I want to understand what may have an impact on its neighborhood. Okay, maybe because of, if you raise an FAR, how much is the economic impact that government may have, because of you will have a lot of when once the FAR is raised. So, you will have a lot of income in through building property issues, etc. So, when you are looking at that, so you can do such analysis when you have such when you have a buffer. So, you will fix up a certain amount of buffer. So, if you increase the buffer in this region, this is the amount of impact. If you increase to this, if you increase to this. So, that is how certain additions are considered when they are actually, when such big infrastructures are coming up. If you are looking at a point, so let us say that if there is a new infrastructure that is coming at a point, let us say a new flag post is being put up. Okay, or if there is a new signal has been put up. So, what they try to do is that if that signal comes here, what may be the effect on the across that entire region, and how many signals are required at that particular point, and how it is going to affect the traffic load in the entire region. So, that analysis can be easily done with just a buffer. Okay. So, first they fix up one buffer and see what is the load, then they fix up the next buffer and look at the load where there is the least. So, they try to maintain that region as one signal corridor. So, the next signal corridor is placed in the next region. Similarly, when you are looking at area, I have given you an example yesterday about the urban area. For example, let us say this is one of the city, okay, or let us say it is a lake, whatever you may consider it too. If a city is there, so I want to understand what is the growth of that particular city over a period of time. Okay, if many cities like mega cities of India, it may be Delhi, it may be Mumbai, or some very big cities like Chennai, Hyderabad or Bangalore. So, what they try to do, normally the phenomena is it starts at the center, there is certain growth at the center and slowly spreads towards the outskirts. So, now with different phenomena because of different decisions by the government, so there may be a spread in different regions. So, then you had national highways, then you have your state highways. So, based on this there may be a spread outside the city boundary also. So, what you do, you have a 2 kilometer buffer or a 5 kilometer buffer or a 10 kilometer buffer. Once you have understood that, then you can find out at every instant, at every buffer that you have considered. So, you can find out exactly where the urban area is intensified. For example, if you take Bangalore, so Bangalore if you try to analyze, so once you see the outskirts, it may be towards the Bangalore south. If you see there are a lot of developments that would have happened, then towards Nelbangla they would have happened, there would have been lot of developments because of the highway connectivity towards the Bangalore. So, that kind of analysis, how the how actually the skirting of the urban area happens can be easily analyzed. It can be done using different metrics, etc., for different analysis. So, that is how the buffer is extremely useful in terms of analytics. Okay. So, then operations on a overlapping polygon. So, these normally when you have polygons which overlaps, they actually create issues that are in the disguised boundaries. Okay, it may be because of the spurious polygons. You have one polygon like this, another polygon sitting like this. So, it may be because of certain digitization errors, or it may be the errors because of different sources that have been collected. So, there may be different solutions to look at it. The first solution is designate boundaries of one feature as a dominant boundary, okay, which means to say if there is two polygon, if there is a polygon that is this is one polygon and this is another polygon, let us say like this, sitting like this, okay, exactly like this. So, if I designate this polygon as the major boundary, then this should sit something like this. That is what is one of the solutions. Then otherwise eliminate polygons that have area smaller than the critical threshold, delete that area at once. So, you can find out what is the threshold area. Then pass a smoothing window over the polygon coordinates. This can be used by fuzzy tolerance, very easily done, and most studies do this. They do a smoothing window so that all spurious polygons are removed or adjusted in the way that it has to set on each other, okay, or sharing the same common boundary. So, that is about how the overlaying polygon is done. Now, the next thing is connectivity. How do you find out entities that are directly linked in a database? For example, linkage can be spatial, cannot be even spatial, but it is attributed to be spatial. So, how do we do this? For example, let us say A is a direct neighbor of B, okay. So, A is a direct neighbor of B, or A is connected to B, that is how we speak. A is a direct neighbor of B, or A is connected to B by a topological network. Okay, if we consider a point A and a point B, both are direct neighbors, but they are connected via topological network. When I say topological network, the topologically connected lines use explicit information in the spatial database, determine the relationships among them. Neighbors is a relationship, okay, are connected by such distances and have such topological connections is again a relationship, okay. Always spatial database are related with relationship, determined by the relationship. Inter-entity distances over a network can be used to determine indices of interaction. Analysis of connectivity over a topologically directed network can be used for determining emergency services or optimizing a delivery route. It can be used for any kind of analysis. I am just giving some examples of where a particular analysis can be used. Entity attributes identify the character of a connector. What is the different connectors? I have given you example of what is a connector, what is a node, and how they are connected across each other. So, the very important thing that I have to point out here before I finish off the basic part of the analysis is that people have to understand certain things when you are looking at GIS. What are the things basically you look at is there may be a lot of logical, there may be a lot of numerical methods to retrieve spatial entities or compute spatial entities or do any kind of analysis or any kind of operations. So, you have to look at exactly what is valid. Okay. So, please look at the theoretical explanation of how you are applying a such a particular tool or why you are applying a particular tool. For example, some of those students who actually put in their resume as I know GIS, okay, but when they come to the lab and so I ask them, so why have you used a particular tool, they would not be able to explain. They would say that this particular software has this tool, so I have used this to do the analysis. No, that is not the right way. So, you should be able to understand and interpret why that particular tool is there and why it has to be used. It may not be the best tool that can be used, but if you understand the science behind it, it is much easier to actually even manipulate that tool for the analysis that you have to do. Then numerical procedures can be applied to inclusion and intersection problems, proximity analysis or analysis of relations over topological connections. So, when you are looking at this topological connectors, it is extremely important for you to analyze what kind of relations are there. So, without relations, most of them try to utilize the way the analysis is done, but they do not ever think about what is the topological connections that exist. It may be a non-existence all throughout the period. So, but look at the entire topological connections and then derive what are the spatial relationship is there. So, please look at how topologically each of these are connected. Okay. We can combine methods, create models, analyze complex spatial problems, but when you are creating models, be careful on what is the model behavior, why are you adopting that particular model. Okay. So, and what kind of analysis you would be doing. So, you have to plan it first and look at what kind of models you will be looking at. So, many data analysis operations are not commutative. Okay. So, keep this in mind. The sequence of analysis operations is very important, the way it is operated. So, you cannot say that I have used this operator. So, I have used this first and this next without any logic. You should have a certain logic of why it is being used. Then spatial modeling permits what if exploration of a different scenarios. Okay, this is very important in terms of spatial modeling. Always look at scenarios which are the models wherein you create scenarios. So, it would give you the more flavors of how the model behaves at different contexts. So, your model will be more successful in case it can give you better results at different contexts when you use what if scenarios. If many brains work across, so those brains have various ways of thinking. So, what if actually gives you the exact way of replication of the real world scenario. Spatial modeling also lets planners learn to be learn from digital mistakes. So, that will help them in a larger way, but only thing is you should be good enough to understand, which means that if you can understand the basics, then it is easier for you to interpret what do you mean by a digital mistake. Okay. So, these are the things that you have to consider. So, as I said, first we looked at point in polygon analysis, wherein we looked at what is a simple problem, what is a complex problem, and what is a problematic problem. Okay. So, look at those issues when you are looking at point in polygon analysis, and we looked at how the overlapping entities can be operated. For example, we looked at how the line entity is operated on a polygon, or how a line entity is used for various analysis. Then we looked at vector overlay, buffering we discussed about how buffering can be done, whether it is urban scenario or whether it is application to any natural resource management, whatever you can do it. Then distance relationship, that is extremely important. How do you do a distance relationship? Probably one can understand its applications in a very large context when you are developing the entire database for a particular region or city or a university. Then we looked at connectivity, so that is extremely important. And finally, I ended this particular class with certain cautious things that you have to look at when you are looking at spatial analysis. So, in the next class we would take up the last part of how do you do an analysis is the advanced analysis. What are different advanced tools do you have? Okay. So, once we have understood this, if you have understood the advanced tools, at the end I would also give you certain ways of how what is the issues when you actually look at the GIS as a data, okay, as a tool, as a data. So, that is how would be the next class. So, until then, have a nice time. Thank you very much.